typical boat, for example, with a couple of inboard engines, gas or diesel, medium boat, 36 feet, and I want to install an autopilot system. What equipments I need to create the autopilot configuration? You need to take a decision what type of autopilot I am going to use. Raymarine, Furuno, Garmin, any, take the decision. Remember that we are going to refresh the components. Component number 1 is the computer. No, the computer. Component number 2 is the drive unit, the hydraulic unit, drive unit. Component number 3, GPS and 2 sensors. What sensors? Rudder sensor and the other one? Heading or gyro. Oh, the display, yeah. Another one, the servo cylinder, the servo actuator. Okay, we are going to refresh. Computer, number 1, computer. Display, rudder sensor, compass, heating sensor. What is this?
Servo cylinder.
Servo actuator. And the drive unit, no? The hydraulic unit. And that's it. Yesterday, we talked about the typical steering systems, no? We checked the mechanical with cable, it's hard. We check the hydraulic, the typical hydraulic with the pump, and the cylinder. What type of cylinder is used in power steering systems? Double shaft, double action. We are going to return to the boat. This is the typical center console boat with a typical 1 outboard. The configuration for 2 outboards or 3 is the same. I have the wheel. What is this?
The helm.
Is the hand pump. The hand pump. It's a hydraulic pump. Let me explain what is the meaning of hydraulic pump. Look at this. This is a typical oil pump, engine oil pump. Where is located the oil pump in an engine?
Inside the oil pan.
In the oil pan, submerged in the oil. And this oil pump suction oil here, and send oil at high pressure. Because the gears with the movement compress the oil and send the oil at high pressure. This pump internally is pretty similar to this one. Collect the fluid. This pump have the reservoir on top, and in the bottom the gears similar to this one. Compress the fluid and send the fluid in this direction or this direction to move the actuator like this or like this. Where is located the servo valve or the body of valves? You see here, neutral position, forward, yeah, left side or right side. This element internally, the plunger, is moving with this. Plunger in one direction, plunger in the other direction. You understand? This is the typical body of valves. Oh, in other scenarios, you remember yesterday in the transmission, the diesel transmission, you remember? 2 solenoids to move it, this element in this position or that position, for forward or reverse, no? And we have other scenarios where we leave an actuator and the pump, the actuator is manual. Look at this. This is the pump. And the fluid goes for starboard side and the fluid goes for port side. And this one is the return if I have a separate reservoir. And the top one to connect with other helm on top because I have pilot helm and fly bridge. Okay, that's the pump. What is this?
Reservoir.
The reservoir. I added the oil over there. When I added the oil, I let open and I bleed the system. I eliminate the bubbles here.
Yeah.
In the hydraulic class, I am going to explain the process to eliminate bubbles here. You open this one. You open this one. You eliminate the air, and now the system is completely soft. Okay, this is the typical hydraulic system. Okay, in your car, it's exactly the same. Look at this. In your car, you can move the wheel in your car if the engine is off, but it's a little, it's hard, no? Mm-hmm. But you can. Yes, you can. It's a little hard,
yeah.
But you can. And it's hydraulic. It's hydraulic. It's exactly the same like the system in your boat. You remember what is the secret number one in a hydraulic circuit? Why the hydraulic circuit is magic? What happens internally in a hydraulic circuit if the circuit is closed?
Transmit. completely.
Transmit exactly like you apply in any part. What component is constant?
Pressure.
The pressure. If that system internally, the pressure is 50 psi, is 50. It's constant. Example of a completely closed hydraulic systems.
The brakes.
The brakes, other complete closed hydraulic system in your boat, in your car.
The steering.
Excuse me?
The steering.
The steering is closed.
Cooling system.
The cooling system. How many times you need per week added coolant in the cooling system in your car? Never. Mr. Lopez, but suddenly, 2 years later, I need added a little. This is because you have a leak. You have a leak. If you have a leak, it's because you need added. That's not normal because it's a complete hermetic closed system. How many times you need recharge refrigerant in the air condition in your home? If you need added periodically, it's because you have a leak. Excuse me, when you have a leak, in that moment, in that circuit, the pressure is constant? No. In that moment, not constant, because air is entering. And that's not good. Okay? Those are examples of a completely hermetic closed hydraulic systems. Give me example of other hydraulic circuits that they are not fully closed. They are semi-closed.
Raw water.
Excuse me?
Raw water.
Yes, and fresh water. The fresh water in your boat is pressurized. When the fresh water pump starts, you hear in your boat the pump and pressurize the fresh water. When you open the shower, the faucet of the shower, water is coming out, you take the shower, and you hear that the pump start again to recover the pressure of the system. No? That system, the freshwater system, is full hermetic closed, is completely closed? No, it's semi-closed, because when you open the faucet and you release pressure, and the pump needs to start again, no? That system is not completely closed, it's semi-closed. Okay, give me other example of other hydraulic circuits that is not fully closed. Other one is the oil, the lubrication system in your engine. The oil pump is submerged in the oil pan. When the engine is running, the oil is pressurized, enter, lubricate the crankshaft, continue, lubricate the camshaft, continue, blah, 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 and on top, reach the rocker arms and go down for gravity. In that moment that the oil reaches the valve cover, is atmosphere pressure and return for gravity. This is semi-closed. It's pressurized in the bottom, but on top, no. You understand?
Right.
Okay, all right. Okay, suppose that we are in the boat that we have before. The wheel, the pump, and the actuator. What happened in this boat? 1 second, Papa. What happened in this boat if with the same pump, the same wheel, the same fluid, I added other 2 outboards? What happened with this?
It's harder.
It's a little hard. I can move it, but it's because I have more weight, no? More engines. How can you fix it that? How can you improve that system? I need install in series other additional pump. Normally, the pressure produced for this type of pump, manual pump here, is around 25-30 psi. 30 psi of pressure. I need increase the pressure in the system. Suddenly, what happened in the morning? You wake up and normally after the first step, you drink coffee or you drink orange juice. This is a booster in energy, no? You need extra energy to start. After that, you can continue. You don't need drink more coffee. No, you drink one coffee or two, and that's it. You have enough extra power. Okay, we need added other pump in this system to improve the movement. Pay attention to this. If you check in the back of this pump, you have one line for starboard side, other line for port side, coming from the pump. You see, starboard side and port side. Everybody follow me? What happened if I cut those lines, and I insert in series a pump, electric pump,
Extra
and
power?
when I start my engine, with the ignition switch of the engine, I start that electric pump. What happened when I move this one right now with that pump running?
Gets even easier.
Oh, wow, it's too soft. Oh, this. What is the name of that pump installed in series? Power assisted pump. It's an assisted pump to this system. Can I remove that pump? Yeah, you can remove, but the system is a little hard. It's better if you put the assisted pump because now it's soft. It's clear? Because I have extra pressure. Look at this. Suppose that the new pump, the new assisted pump is 60 psi. And originally this one is 30 psi. Now I have 90 psi. And the pressure is it's excellent. And the cylinder is moving easy. This is an electro-assisted pump. That's nice. There are other assisted pumps, mechanicals. Not electrical, mechanical. Yeah, this pump that I mentioned here is electrical. Come on, 1 second. Look at this. This is the helm. Look at the port side, starboard side, port side, starboard side. Forget that one. And now port side enter here, starboard side here, and port side continue here, and starboard side enter here. And this is look, electrical power assisted unit. When I start my engine, this pump is on, and when I move, the wheel is soft. If this pump is off, okay, I can move it, but it's hard. Ready? What is the function of this? Assist the system. Power assisted unit, and that pump is electrical. What happened in this situation? I want to interrupt the movement of the fluid in this car with this mechanical pump. Look at the pump. This pump is not electrical. This pump is driven by
Belt.
the belt and the crankshaft of the engine. When the engine starts, it's moving this pump. This is the reservoir of the pump. The oil is here, and the gears are here. And this pump suction oil here and send oil with high pressure here to the cylinder, to the ram. Look at this. In this engine, I replaced in this laboratory the gasoline engine for this electric motor. But this is a car. This is the engine, this is the carburetor, this is the gasoline, and this is the mechanical power assisted unit. Mechanical. It's hydraulical, but the movement is with valve connected to the crankshaft of the engine. Oh, in this moment, you can move those wheels, but it's hard. I am going to start the motor, and now look at this. Look at this. What is the pump is running and pressurize the system with extra pressure, and this is the result, guys. Everybody follow me? Nice, no?